Okay, this one's on power to power with exponents. When we're looking at our notes. Alright, so on here, I've got 2 squared, right? That means I have 2 of the 2's. Now, if I have 2 squared cubed, that means I have 3 of the 2 squareds. Does that make sense? So on here, I've got 2 squared. This is my 2 squared cubed, right? And this is my 2 squared times 2 squared times 2 squared. You guys see how I broke that down? So now how many 2's am I actually multiplying? 6. 2, 4, 6 here, right? So really, I did 2 to the 2 times 3. There's really 6 of them. So now here, 4 to the 5th, 3 times, right? If I have 5 4's in each of them, so this one's got 5, this one's got 5, this one's got 5. How many do I have? 15. So I really have to the 5 times 3. So I have 4 to the 15th. So that's going to be our rule. We have power to power. We have a power to another power. You're just going to multiply their exponents. It is pretty easy. Okay, on here, what I need to do. What's the negative 3's exponent? What is it? 5. There's not an exponent there. What is it? 1. So negative 3's exponent is 1. And since we're inside the parentheses, okay, so I've got negative 3 to the negative 2, this whole thing, negative 3, is going. Does that make sense? It's included with the number. So I have negative 3 to the 1 times what's my other exponent? Negative 2. M to the 5 times negative 2. N to the negative 6 times negative 2. Everything. Everything. So I've got negative 3 to the negative 2, good. M to the negative 10. N to the okay, where does the negative 3 need to go? Up, down, stay the same. It's on the top, right? This is all this over 1, right? If it's not on the bottom of the fraction, it's automatically on the top. So this one needs to go down. This one, down, and this one stays the same, right? So on the top I have n to the 12th. On the bottom I have negative 3 to the negative 2?
Or negative 12.
Positive 2. Think about your rules. When you do the reciprocal, it changes the sign, right? M to the 10th. So now I have n to the 12th. What's negative 3 squared? Negative 3 times negative 3 is what? 9. M to the 10th will be our final answer. So do you guys see the progression that I just did? That's what I want to see on your problems. If you work it out this way and you're showing all your work, you shouldn't have a mistake. Okay, the next one. This is a 2-part deal. So I have 6 to the 1 times 2. H to the 4 times K to the 3 times 2. Now the second part, I have 2 to the 1 times negative 4. H to the
Negative 9.
times K to the times. So I have 6, sorry, 6 what? 6 squared. I'm going to bring the other coefficient out. 2 what?
Negative 4.
To the negative 4. H to the 8th, good. H to the 20th, good. K to the 6th, and K to the...
Wait, so all this like
Okay.
next to each other?
So what I'm doing now, what I'm doing here is I'm combining like terms. I'm putting my terms together. Okay? So that it makes it easier for me to look at it and say, okay, I have these H's. Now that I'm multiplying bases, what can I do? Add their exponents, right? Okay. Now, 6. 6 is a base right now, but do we have another base 6? No, so I have 6 squared is what? 6 squared is 36. So that's what they're wanting here, 36. Two to the negative 4. 2 to the negative 4, how do I fix that?
We put negative 4 to the bottom.
So I have what?
So we'll have 2 over negative 4. 2 over 4.
1 over, very good, 1 over 2 to the 4th. And 1 over 2 to the 4th, so 2 times 2 is, times 2 is, times 2 is 16. So I've got 1/16 here. Now I have 2 base H. When I multiply, what do I do to their exponents? Add. So I should have 28 and K 18.
Use that 8. So how do you do that for H?
Because when you have the same base H, when you multiply bases, you add their exponents, right?
Oh, never mind. I did negative 4 and 8.
Okay. So this should be 1/16. I have H to the 28th, K to the 18th. My H and K aren't going to change, so this is going to be 28 and 18. And now we just need to multiply 36 times 1/16. What is that? It's 36 over 16, right? Can that reduce? What can it reduce by?
Wait, no, 9 over 6. No, 9 over 4. No, 4.
We can reduce it by 4. Let's see. Okay, let's see if we do it by 4. What's on the top? 9. What's on the bottom? Will that reduce anymore? No. So this is 9/4. H to the 28th, K to the 18th. Or we could write it 9 H to the 28th, K to the 18th, all over 4. That's the other way we could write it. But this answer and this answer are the same. Does that make sense? It's a lot of work, it's a lot of steps, but this one problem we covered, okay, we covered everything but division. And this one we had power to power, right? We had multiplying. When we multiply, we had to add their bases. We did coefficients in this one, right? We had negative exponents. So when we had this negative exponent out here, there's actually another way to do it, and I'm going to show you that in a little bit, all right? So there's actually 2 ways to do this problem. When raising a power to power, we what the exponents? Multiply. We're not adding the coefficients.
Okay.
I really don't even know why that's on there. When raising a power to power, we multiply the exponents. The coefficients are included. If there were, let's see, the coefficients would get the power though, because they have the power of 1. I'm thinking maybe if they're thinking if there's coefficients out in front, then we would be multiplying the coefficients too. Okay, I'm not really worried about this part here. I'm worried about that first line. We multiply the exponents. Power to power, you multiply the exponents. Alright? Let's try these. Okay, remember everything in that parentheses has to have an exponent. So what's the 4's exponent? A 1. So this is 4 what? 4 to the 3rd, a to the 15th. And 4 cubed is what? 64? Okay, now this is the one that I was telling you. If you have negative exponents out here, there's 2 ways you could actually do this problem. So let's look at number 3. Okay, one way you could do it is just go ahead and multiply these exponents. So I'd have m to the negative 3 times negative 4 is 12, and n to the negative 16. And when I fix that, what's on top? M to the 12th. What's on the bottom? N to the 16th. Good. The other way we could do this problem is if we have a negative exponent out here. Okay, and we have a negative exponent in here. There's actually 3 ways. Okay, one way, if you wanted to start from the inside of the parentheses, fix that first, it would actually be a longer way. We would have, if I fix that first, I would have n to the 4th over m cubed. Does everybody know what I'm talking about? All to the negative 4?
Yeah.
Now, since this is negative, to fix that I could flip my fraction, right? So I could have m cubed over n to the 4th, make this a positive 4 now, and then distribute. So then I would have m to the 12th over n to the 16th, which is it's our same answer. You see what I'm doing? So that way would be correct. And then the last way you could do it, which would also be correct, is if you fixed the exponent on the outside first. So if you wanted to do that, we would have 1 over m to the negative 3, n to the 4th, all to the positive 4. You guys know what I'm talking about? I made this positive by flipping the fraction. Then you could distribute. So I'd have 1 to the 4th, which is just 1 over m to the negative 12, n to the 16th. Fix that, so you have m to the 12th over n to the 16th. There's really a lot of ways to do these problems. Okay, everybody's paper may not look the same, and that's all right, but you should end up at the same answer. Okay, if you see something first and you want to fix it, go ahead and do that. Just make sure you don't break any of the rules. Okay? It's all right if your steps aren't the same. When I look at your stuff, I'm going to be able to tell what you did. All right? Okay, let's go over a few more. Number 5. Was there anything to do here? No, so I have 2 to the 5th times what? 2 to the 8th. Good. Now I have the same base of 2. I'm multiplying. What do I do to their exponents? Add. So I have 13. And we're just going to leave it like that because it'll be a big number. You can. It's just going to be a big number.
What about number 2? It's has negative 12 as our exponent.
Okay, so that one would be what? Base 2 to the...
Yeah, negative 12.
negative 12.
That's right.
And then what? Huh? Flip it, so I should have
1 over 2 to the 12.
1 over 2 to the 12th. And you could work that out, but it'll be a big number. You can leave it like this. If it's something that's going to be a huge number, you can leave it, or you can work it out if you want to. Okay? Let's do number 8 is a good one. Okay, on this I have what?
X to the 15.
Good, x to the 15th, y to the 9th, x squared, y to the 10th. And we're multiplying everything, right? So now I've just got to combine like terms. So an x times an x gives me x to the 17th. Y times y is y to the 19th. Okay, let's go. Okay. You got it? Okay, let's go to number 14. Okay, you guys tell me. You want to flip it first? Okay, what do you want to flip first?
1 over
1 over what?
negative 6 there. Well, like
A
negative 6.
to the negative
Or
6.
it's going to be positive.
It'll be a positive 6, yeah? Really what I would suggest, because you're trying to do 2 steps in one, and that's okay, but it can get confusing. If I were you, I would do a cubed b to the 4th, all squared, right? Change that first. Do that step first. And then over here we would have 1 over a to the negative 3, b to the negative 5, all to the, what was this number here, 3? What was that? That was a 4. All to the positive 4 now.
Hey, why are we flipping?
You don't have to. You don't have to. I'll do it the way you like to do it here in a second. Mason wanted to flip it first. So if I do this, then I would have 1 squared, right, which is 1. So I have 1 over a to the 6th, b to the 4th, times 1 over a to the negative 12, b to the negative 20, right? Is this what you're doing, Mason?
Yeah.
So then we're going to fix these numbers, right? Really, even from here, there's 2 ways you could go. From here, you could go ahead and say, I've got all of these on the bottom, let me add them first. Or you could fix these negatives, put them on top, and divide. You could multiply or divide. Which way do you want to do it? Multiply, so you would have 1 over a to the negative 6, b to the negative 16. And then fix that, what would you do?
Flip it.
Flip it. So you'd have a to the 6th, b to the 16th would be your final answer. Oscar, do you want me to do it your way? I can do it. Let me do it that way so you can see it. Mace, did you get all this?
Yeah.
Okay, I'm going to erase this and do it the other way. Okay. Oscar, you wanted to multiply first?
Yeah.
Okay, so we would have a to the b to the times a to the b to the. Okay, now what do you want to do? Do you want to fix them or do you want to add them? Okay, so then you would have a to the 6, b to the 12. That's the same answer, right? You see what I'm saying? Or if he didn't see that, if they added, they would be positive, and you wanted to fix these, you could say a to the 12th, b to the 20th, over a to the 6th, b to the 8th, right? And then say, let's divide. Take 6 away, take 6 away. I have a to the 6th on top. Take 8 away, take 8 away. I have b to the 12th. You see what I'm saying? There's so many different ways to do these problems. As long as you're doing them correctly, since it's all in one term, it doesn't really have an order of operation. Just as long as you're not breaking any rules. Okay? Do y'all see any on the rest of the page that y'all really want me to go over? You think you can try them? I think y'all can do these. Okay? Y'all finish the rest of this.